Okay, so we're going to review some table topics, but more importantly, we're going to talk about conditional probability. And while we briefly mentioned that in the prior unit, it was very, very brief. So we know the conditional probability is a given situation, all right? Given, what's the probability something will happen given that another event was happened? We've already said givens in the denominator, and we keep saying the intersection is always intersection over given, which is essentially the joint probability over the marginal. The numbers marked in black are the joints, the ones in red, with the exception of the total, are the marginal. So this is a marginal, this is a marginal, this is a marginal, this is a marginal, and these are my joint. Okay, so let's go back. We need to look at this right here. This says the probability of A, and that line has a meaning. This line means given. So the probability that A given B equals the probability of A and B over the probability of B. And that makes sense because if this means given, we go, oh, B's in the denominator because that's what was given, and the intersection's on top. So the intersection over the probability of B. Now this right here, this equation is one that's on your formula chart. So that's there. And conversely, we could have written, this is not on the formula chart, but essentially means the same thing, is the probability of B given A equals the probability of A and B over the probability of A. Once again, my given is in the denominator and the intersection's on top. So slightly different, but you can see that we just rearranged the equation based on how it's set up. So let's look at some basic probabilities and talk about it very briefly. This is a fairly short video. The table gives the results of a survey of drinking and smoking habits of 1,200 college students. Rows and columns have been summed. So we have 900, 300, 480, 720, and basically this plus this is this. So we have 480 people who smoke, and we have 900 who drink. All right. We also see that we have 315 that don't do either. That do both. And we have 135 that don't smoke and don't drink. Okay. So what's the probability that a student smokes? Well, that's simply 480 out of the total population of 1,200. What's the probability that a student drinks? That's basically 900 drinkers out of a total of 1,200. What's the probability a student smokes and drinks? Well, that would be the intersection. And the intersection is here at 315. So 315 over 1,200. What is the probability a student smokes given that the student drinks? So here we have a given situation. So we know we're working with the intersection over given. And what are we given? We're given that they drink. And so there's 900 of them. And of that, we're looking for the intersection. And the intersection occurs right here at 315. So 315 over 900. The next question, what's the probability that a student drinks given that they smoke? Once again, we have intersection over given. But now we're looking at the smokers, given that they smoke, there's 480. But our intersection is exactly the same because we're still dealing with smokers and drinkers. Okay. Oops. So I should have written 315 over 480. All right. So the next question says, why are D and E, the probabilities different for D and E? And the simple answer is D was out of the group of drinkers, and we had 900 drinkers. So we had 900 drinkers, and only 315 of that 900 smoked. When we got to the other one, we said, okay, we have 480 smokers, and of that 480, 315 drink. So we're taking it out of two different groups. And because we're looking at two different groups or two different subsets, we have different probabilities. Finally, it says create a Venn diagram based on the table values. It says do it based on the actual, and then it also says do it based on the probabilities. So this is what we're looking at. First off, we have 315 there. And the reason we have 315 there is that's exactly the number of people that did both. Because when I look at this, oh, we have 315 that drank and smoked. So that's our overlap. Well, we had 900 drinkers, but because we have 315 here, we need to subtract. So we have 585. So this 585, they drink, but they don't smoke. They drink, but they don't smoke. Over here, we had a total of 480 smokers, but 315 of them drank. So we subtracted that out, and we have 165 who smoke but don't drink. So once again, 585 who drink but do not smoke, and 315 who do both, and 165 who smoke but do not drink. Well, that accounted for, that did not account for everybody. We had 135 that are out here, and they don't drink or smoke, all right? So then, how do we get the probabilities? Well, to get the probabilities is very easy. All we did was take these values and divide by the sample size. So all we did was take them and divide by 1,200. So if I take the 585 divided by 1,200, I get this. The 315 divided by 1,200, I get this, and so on and so forth. Please remember, it has to be a valid probability distribution. So all of these values together have to sum to one whole. Okay? All right, thank you so much.